So what's up, guys? How's the comments? How's everything? How are you guys? How's your summer? How y'all been? I've been chilling, I've been straight. So yeah, now I'm downstairs. Yeah, my teeth are kind of fucked up, but I don't give a shit. I can still smile. Just kidding. I'm pretty funny too. It's just I look bored as hell and tired as hell. So I'm gonna have some friends come over later on. We're just gonna chill and play some video games. The real shit. So here are some of my notes. I'm trying to look for them. These are all my notes, by the way. I'm gonna read one because I'm really bored. So this is really interesting, guys. Like this is really interesting. So there's stuff about the eyes. The eyes are really important, because it helps us see. Our eyes are our being and shit, and it makes us feel alive. And existence is like pretty much what's in our fucking head. So yeah. So here it goes. It says this is the eyes, like how you study the eyes, how they work. It says the central 10 of the visual, which represents only 1% of the total visual field. That means we have only 1% of our sight. So Hubble and Wise, 1962 and 1968, found that different cell types tend to be more numerous in some layers than in others. For example, wavelength selective cells are found in all layers, but are more concentrated in layers 2 and 3, Johnson et al. 1 in 2001. See research studies the spatial transformation of color in the primordial visual cortex of the macaque monkey, and Johnson, Hawkins, and Shapley. The cortex. The cortex can also be divided vertically into columns on the basis of receptive field properties and ocular dominance columns. So dominance, like XY and big Y and little x, like our inheritance. And it says vertically columns on the basis of receptive field properties. So an ocular dominance is like our eyes. And all binocular cells share the same degree of ocular dominance. That means our eyes are literally the same and we literally feel the same, and it has to be completely different in order to change your life. So all that shit's in your DNA and in your eye socket, which connects to the brain. So it says in orientation, selective cells share the same preferred orientation. Layers 2 and 3 of striate cortex contain blobs. Layer 2 and 3 of striate cortex contain blobs. That's really important to know. Layers 2 and 3 of striate cortex contain blobs, which receive projections from cononuclear cellular LGN fibra and are often color selective, Landman and TSO 2002. So Hubble and Wise in 1974, they argued that a 1 mm/second region of cortex can be viewed as a hypercolumn that contains all neural requirements that analyze a particular region of the visual fields. Research activity, illusionary contour perception. So now they have cortical cell response to several stimulus attributes. The majority of cortical cells show orientation, selectivity, i.e. for a given cell, lines or bars at a specific orientation produce the greatest response. About 2/3 of striate cells are complex cells, and 10 striate cells are simple cells. Some striate cells are direction selective, responding more strongly to Raynaud movement in one particular direction. That means we only have one direction. Like one direction. Get it? Some cells respond more to stimulation of one eye than the other, a property called ocular dominance. Some cells are tuned to binocular disparity. So our binocular, we have like binocular eyes. We see like, double-edged. And we also have like properties of like ocular dominance. It's like in our DNA. And many cortical cells are responsive to wavelength, and many demonstrate double opponency. When you like look up in the sky sometimes, you're wondering like the static, you hear all the static and it's all like confusing you and shit. That's not good. It's not good. So our movement is in one particular direction. So how else? Imagine if our eyes changed, we would see all around. It'd be like cool ass shit. And many cortical cells are responsive to wavelength. So wavelength is like motion. Like our eyes are full of motion. And many demonstrate double opponency. Like double opponency. Double opponency. I'm trying to figure that out. Double opponency. Many cortical cells are responsive to wavelength, and many demonstrate double opponency. Almost had that one. Many cortical demonstrate to wavelength. Double opponency. Opponency is a direct right. Opponency is something that we know about ourselves. The arrangement of cells in the cortex is highly organized. Like our eyes are like really perfect. And cells are distributed across the cortex so that the receptive field locations from a topographic map of the visual field. This topographic map is distorted, so about half of the cortical surface maps. I'm going to read that one more time. Cells are distributed across the cortex so that the receptive field locations form a topographic map of the visual field. That's really hard to learn. I have to restudy that. Topographical, so pretty much I get it now. So it says cells are distributed across the cortex. So there's cells in our eyes that are like distributed, it's like direct contact.